Good afternoon to one and all. Today in this session I am going to explain about the operations that are performed on the binary search tree. Before exploring this, I am going to recap that was happened in the last session. That is definition of the binary search tree. It is a special kind of a binary tree in which each node contains only larger values in the right subtree and smaller values in the left subtree. Then, after the definition, I move on to the mathematical representation. That is, we can able to construct 2n cn divided by n plus 1 binary search trees with the help of n distinct keys. With an example also we saw, that is, yeah, if n is equal to 3, we can able to construct 5 binary search trees. Then, construction of the binary search tree in a stepwise manner with the help of 7 elements. With that, we conclude that session. And today, the operations that we are going to learn about the operations that are performed on the binary search tree. First one is searching, and second one is insertion, and third one is deletion. Searching means to search for a particular element in the binary search tree. That means our requirement is to find whether the element what we require is exist in the binary search tree or not. In order to do this, there are certain rules, and assume that the value that we are trying to find is considered as a key. So we are going to compare the key with the value of the root node. If this comparison is successful, the searching process will be completed. That means if the key is present at the root node, then return the root node and searching process will over. Or otherwise, if the key is greater than root node, then searching process will continue in the right subtree of the root node. And the searching process will continue until we will get the key value, or otherwise up to the leaf node searching process will takes place. Even at the leaf node, if it is not there, we will say that that key is not existed in the binary search tree. And at the same way, if the value of the key is less than the root node, same searching process will continue. This time searching process will continue in the left subtree. And we will see one example. Definitely we will get the better clarity. For example, we are trying to find 45 in the binary search tree. As 45 greater than 25, we search in the 25's right subtree. And as 45 less than 50, we will search in the 50's left subtree. In the left subtree of 50, there is a again subtree containing three nodes 35, 31, and 44. As 45 greater than 35, 45 is greater than 35, searching process will continue in the 35's right subtree. And as 45 is greater than 44, definitely searching will continue in the 44's right subtree, but 44 does not have any children, so we will conclude that 45 is not present in the binary search tree. In this way, we searching process will continue in this way. And the next one is insertion operation. Insertion operation means to insert a new element in the existing binary search tree. The insertion of a new key always takes place as a child of some leaf node. So it is a two-step process. We need to find the appropriate leaf node, and after finding the leaf node, we make this new key as a child of that leaf node. What I want to say is, for example, the new key that what we want to insert is going to be placed as a child of some leaf node, but some leaf node is not a random choice. That means with respect to binary search tree, there may be n different leaf nodes may be existed. So this choice of the leaf node is a random one. Definitely, with some procedure, we will find the leaf node. After finding the leaf node, we will make this new key as a child of that leaf node. For example, we are trying to insert the key 40 to the existing binary search tree. So comparison takes place between the 40 and 100. So as 40 is less than 100, we will search in the hundreds left subtree. And with respect to the 100, the left subtree contains the values 20, 10 and 30. As 40 greater than 20, we search in the 20's right subtree. And as 40 greater than 30, we will add 40 to the 30's right subtree. In this way, a new key is inserted into the existing binary search tree. And the next one is deletion operation. Deletion operation means we are trying to delete a node or a particular element in the binary search tree. And it will be happen in three different ways. That means in the first case, the node does not have any child. That means node is considered as a leaf. That means what our requirement is to delete a node, it is a leaf. The node what we are trying to delete is a leaf. And the second case is node contains only one child. We are trying to delete a node and that particular node is having only one child. And in the third case, node is having two children. In these three ways, we are going to learn one by one. First one, we are trying to delete the node with the value 20. Here, this particular node is a leaf node. It is very easy one. Simply we are going to disconnect or remove that leaf node from the existing binary search tree. That means before the deletion of the 20, the binary search tree is like this, BST is like this, and after the deletion of the 20, it is transformed to like this. That means 20 is a leaf node, it is simply disconnected from its parent 30. It is very simple one. And the second case, that means node is having only one child. Before explanation of this particular case, let me let me tell about the remaining things, remaining terminologies. That is, with respect to the 40, 30 is a parent, and with respect to 30, 50 is a parent. This information is needed because we are trying to delete the node with the value 30. As 30 is a parent, as a parent is disconnected from the binary search tree, child is connected to its grandparent. Okay, what we have to understand is, as parent is disconnected from this binary search tree, its child node is connected to the grandparent node. So with respect to 40, 30 is parent and 50 is grandparent. As 30 is disconnected from the binary search tree, 40 is connected to its grandparent, that is 50. So before deletion of 30, binary search tree is like this. So after deletion of 30, it is transformed to like this. And the next one, it is somewhat complex one when compared to the first two cases. Here, deletion of a node having two children. For example, our requirement is to delete a node with a value 15. Here 15 is having two children. First one is 10 and second one is 17. So with respect to this particular case, it is done in again two different ways. For example, with respect to the 15, right subtree. Right subtree of 15 contains three different values. With respect to 15, right subtree is 17, 16, 19. This is the right subtree. In these three values, 16 is the smallest one. 16 is the smallest one. So pluck the least value, that is a 16, and replace the deleting element with this value. That means replace the 15 with 16. And here also there are some terminologies. That means with respect to the 15 right subtree, plug the least value element which is called as in order successor. Its terminology. That means with respect to 15, 16 is in order successor. So replace the deleting element with its in order successor. And in the second way, the left subtree. We need to look at the left subtree. Left subtree also contains three different values, that is 10, 2 and 12. In these three values, the largest value or the greatest value which is called a in-order predecessor. So out of these three values, 10, 2 and 12, the largest value is considered as an in-order predecessor. So replace the deleting element, that is 15, with its in-order predecessor 12. That means 15 is 15 in the place of 15, 12 is going to be placed. So before deletion of 15, the binary search tree is like this, and after the deletion of 15, the binary search tree is like this. That's it.